Hello everyone. Welcome to our video on the definition of the derivative, where we will apply the definition to a polynomial function. So the definition of a derivative. So the derivative is one of our main things that we focus on in calculus. The derivative is the function right here. And we say the derivative, so the derivative, that is f prime of x is how we often say it. So the derivative is denoted using f prime. Notice we've seen this before. This is the instantaneous rate of change. But when we used it in our previous examples, we plugged in a value for x. So we used the numbers. So I deleted them because I deleted the ink on our previous videos because it often freezes the program if there's too much. But if you recall from these, we would plug in all of our, it would look something like this with the 2 plus h or the negative 1 plus h. So they would want us, and there it is right there. The instantaneous rate of change is this formula, except they told us to plug in an x value for it. Here, we're just going to do the general and leave it as x. So this is the instantaneous rate of change. Let's say it like this. It's the general instantaneous rate of change. So what we're going to do is leave x as x. Leave x as x. So we won't plug in a number immediately for it. Maybe eventually we will, but that's the main difference. Okay, and again, this is so important for us. They started to recognize, hey, this is an important function. It should have its own name, and they called it the derivative. So in the derivative, well, it's, so looking at the first couple letters, derive. So the derivative is derived from the instantaneous rate of change. And they said, okay, how about we just call it a derivative as its function, since it was derived from that instantaneous rate of change. Okay, so that's, I guess, a little bit of history on it. Okay, anyway, so let's also read this. So provided the limit exists, so it does have to exist, and x is in the domain of f, if f prime of x exists, we say that f is differentiable at x. So that means it does have a derivative at x. If f is differentiable at every point on an open interval I, we say that f is differentiable on I. So like this polynomial is differentiable at every point. Other problems, we often will see that it's not differentiable at certain points, but it's usually pretty easy to spot and not really a main thing to worry about. Okay, and then one other thing, we have a tangent line is a line that goes through the points of a function that has the slope that is equal to f prime of x at whatever x value we might need some cases. Okay, anyway, let's see how this works. So if you've been, I hope you've been enjoying if you've been going in order, enjoying these types of videos, it's very similar to what we were doing. Okay, so you could try these out on your own after you see this first example to get the hang of it. But let's break this down. Okay, so in number one, it says use the definition to find the derivative. So whenever it says use the definition, they want us to use f prime. So they want us to use this, f prime of x equal the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so that's what they say, or that's what we want to do when they tell us to do it like that. Now, some of you that maybe have taken calculus before, there are certain rules that we will have very soon that speeds these problems up. However, please still use what they want you to use, because the main purpose is to get to improve really simplifying skills. And so those are always going to be around in your math classes. Okay, so sometimes there's shortcuts, but even those shortcuts require simplifying. And so this is very good practice to get better at simplifying. All right, anyway, so let's break this down. All right, so to do this problem, well, again, it's very similar to what we've done, except now we are just going to leave it as x instead of some number. And what we did in the previous problems is we usually did that to the side. Okay, so let's evaluate those two there. So let's evaluate those, and then eventually we'll subtract and simplify. Okay, so let's keep this one in blue though. So the f of x plus h. Okay, so I have my function. I'm just going to change I see the x. I've already changed it there in the f portion, and then now I need to change it in the second on the right side. So 3 times x plus h getting squared minus 4. Now this has to get FOILed. Well, I'm going to use my shortcut technique. So we could write it out. It is multiplied by itself. So remember, it is x plus h squared is x plus h times x plus h. So always remember that it's something like this. However, if it is a binomial getting squared, here's the shortcut. I want to take x and multiply it by itself to get x squared. I would have x times this h. So I'm just looking at these and I say I need to multiply those, which would give me xh. But I'm going to multiply it by 2 afterwards. So 2xh. And then I take the last one, the h, and multiply it by itself, h squared. Minus 4 at the end of it all. Okay, and that's what would happen if you FOILed it. You could double check. It is this, though. Okay, so I'm going to kind of speed up some of these. I hope that we see it well and we could do it. Again, if you need to FOIL it, that's fine, though, with some scratch work just to the side. Okay, and then now this 3 will distribute. So I have 3x squared plus 6xh plus 3h squared minus 4. And then I look at this and I see, oh, nothing's in common. So that is our f of x plus h. And I'm just going to kind of cloud it. There it is. Okay, and then I want to do the f of x, which I marked in red. So our f of x, well, I actually don't really need to do anything. It's right here. It is just the same thing, 3x squared minus 4. Okay, so that notice it doesn't take any work. I could just instantly plug it in. Okay, so here was our scratch paper, or our half of scratch work. Now let's go and use our formula to plug in those expressions. So in the blue was this clouded expression. So 3x squared plus 6xh plus 3h squared, and then minus 4. And then minus the f of x, which is the 3x squared minus 4. Again, this parentheses here in the red, I recommend it no matter what. Put them in, because this minus will now distribute. So we never want to forget that the minus wants to minus everything. So it's a very common mistake I see from students that just write out the 3x minus 4 and then forget to distribute. So the minus 4 gets forgotten. Okay, anyway, so what we do have is in the blue, I don't need those parentheses anymore. I've got 3x squared plus 6xh plus 3h squared minus 4 minus 3x squared plus 4 all over h. Okay, so we're evaluating we evaluated and we plugged them in. We are doing our step 2, where now I'm just starting at this point, I'm simplifying the whole thing, however method it takes to simplify. And when we simplify our goal, we should hopefully get this h that's in the denominator to cancel out. And so in the numerator, we should only have h terms left over. So simplifying, we should only have h terms in numerator once fully simplified. All right, so that we're still simplifying in this step, and if we did it right, we should. So I'm going to highlight the 3x squared minus this 3x squared is 0, and the minus 4 and the positive 4 is 0. So then we are left with, so we have the limit as h goes to 0. We're left with just the 6xh plus 3h squared. And I didn't really need, let me erase that big old fraction. I didn't need it that big. There we go. So, and then that's it, because the highlighted yellow is 0, the highlighted pink is 0. And again, what we have here, that we should only have h terms, and we do. There's an h and then there's an h. So that each term has an h involved. Okay, if I had, say for instance, I forgot to distribute the negative and I had this as minus, then I would have had a minus 8 to the side still. And then that's no good, because I know I can't cancel that h out. Okay, so if you have some leftover constant, probably a mistake was made, and we can go back and try to find it. Okay, but anyway, now it's again very similar to where we've done this before, where our third step is, well, still to continue simplifying, but let's factor. So factor out h to cancel the h in the denominator. And then after that, then plug h equals 0 into any remaining h's. That's not how you spell that. Any remaining h terms. Okay, so if we factor out the h, so there's an h in common in the numerator, so we have this becomes the limit as h goes to 0. So the h is in common, we could take that out, and we're left with a 6x plus 3h over h. All right, and so we factored the h out. Remember, you can check with multiplying it back in. It does give us what's above, but now the h's are in common and they cancel. And we are very close to our final answer. We have the limit as h goes to 0 of just 6x plus 3h. And now I can plug h going into 0 for that there, which gives us 6x plus 3 times 0. Notice I don't have the limit anymore because I'm applying the value into the h. And while 3 times 0 is 0, so this is just 6x. Okay, so what we just found, let's put it right here. So the f prime of x, I didn't write it every line, notice that, but that's what we did just find. We did just find this. So we have f prime of x is 6x. Okay, so this is the general form for the slope of our tangent line. So this is, again, the general, let's say it as the general instantaneous rate of change. Okay, and where this is useful is for like number 2. So on number 2, they want us to evaluate these values with this new function here. Okay, well, this is super easy now. I have f prime of negative 2 is, well, 6 times negative 2, which is negative 12. That's it. Okay, and what this represents is the instantaneous rate of change for our equation at x equals 12. We'll go ahead and we will graph this, and I'll show what it is visually, but let's go ahead and get these other ones. So there, that one's done. Let's get f prime of 0, which is 6 times 0, which is 0. There's that. That one's done. And then one other, f prime of 4 is, if we plug that in, we have 6 times negative, oops, not negative 4, I don't know where I saw that. Just 6 times 4, which is 24. Okay, and what these represent, so this is the slope of the tangent line at the value that we plugged in, x equals negative 2. And this is also, let's abbreviate slope of the tangent line as m with little tan underneath. So this is m tan equals 0 at x equals 0. This is m tan equals 24 at x equals 4. Okay, so that makes these so much easier to do. From before, okay, so from the previous section, they would plug the negative 2 in, so now I don't have to do that. So the instantaneous rate of change, just to show it as the previous one, we would have done f of x, well, the x is negative 2. Let me just set it up immediately like that. So we don't have to do it like this anymore. So the negative 2 plus h minus f of negative 2 over h. So that's how they would have done it from the previous one. And then we would have had to do it 3 separate times with this limit. Okay, so this general form is helping us speed things along. Yes, it still takes long here, but it's sure better than doing 3 separate limit problems. So if we were to do this, it would give us negative 12, but we have a very much faster way to do it now. Okay, anyway, let me go ahead and graph this Okay, so I've got my scientific. Let's go to the graphing. Ready, and I'm going to plug in the original function, so the 3x squared minus 4. Okay, so I've got 3x squared minus 4, like that. Okay, and I've got my projector. Let's do projector mode. Okay, so that's the original function. And what I want to do is let's just go ahead and show where I've got, well, let me try to see it all. Okay, so they tell us what the slope is. So at x equals -2, so here is -2. Let me find it on the dot. So I have the point -2, 8. But what's happening here, and it's maybe a little tough to kind of see on it, but what is happening is if I were to draw in the line through this point, it would look like it has a slope of -12. Okay, so at -2, 8, I would have that slope of -12. Okay, and let me just go ahead, I can maybe try to plug that in real quick. So y minus, and we'll show how to do this very soon. Okay, so that is the equation there that has the slope of -12. Okay, and there's that point where they're connected. So they each go through that point, the -2 and 8, which I'm having trouble clicking on. But that's what it's showing. It's showing that the graph, this curvy graph that's a parabola, matches this kind of line at -2, 8. So that's all it's trying to show us. Okay, and notice if I zoom out pretty far, it looks like the blue line is pretty similar to the red graph for a lot of it, but then it starts to separate. Okay, so anyway, so it's just showing, it's telling you how quickly this graph is changing, and it's showing it's changing a lot. It's got a very steep slope when we have -2. Okay, anyway, so that's just a picture of one. Again, we'll get into it further, but I just wanted to introduce it now to kind of give you a sneak peek. Okay, so, but that's it. Okay, so let's take a break. We'll do a couple others in separate videos, but for now, I think that's good. If you do have questions, please let me know. Otherwise, thank you for watching.